Okay, so question 1. So you're given electronic configuration of 5 atoms. So you look there, it's atoms, it's not ions. Because this is an atom, it means the number of proton must equal to the number of electron. That's why overall no charge for an atom, because they balance out, yeah? Okay, so which electronic configuration represent each of the following descriptors? They may be used once, more than once, or not at all. Okay, sodium atom, if you have a look at your periodic table, so sodium is in group 1 and the configuration is 2 because you fill up to helium. So follow your periodic table and then you fill across the second period, all of them up to neon, so that's why it's 8. And then now you're up to sodium, so it's like playing the ladder snake, yeah? So you go from hydrogen to helium, there's 2, from lithium all the way to neon, there's 8, and then now you're at sodium again, so you stop there, it's just 1 because you're in group 1 outer shell electrons, yeah? So you're looking for 2 at 1, and that is C. Okay, so 2, 8, 1 outer shell electrons. In hindsight, if you just look for 1 outer shell electron, you can tell already that C is the only sensible one. Okay, so here there are 2 outer shell electrons. In fact, I think this is helium. Okay, there are 2 outer shell electrons there, so you're looking at group 2. Okay, because 2 outer shell electrons, there's group 1 outer shell electron. Here you have 1, 2, 3, 4, 5, 6. So this is group 6, and then this is group 8 again. This is noble gas as well, so it's group 8. All right. Anyway, next they are looking for an atom of a reactive. So you want reactive non-metallic element. So the only non-metal here would be group 6, that would be D. Okay, and then if you go for like these noble gases, they are non-metal, but they are not reactive because they have full outer shell configuration already. So the keyword already is reactive, yeah. An atom with a proton number of 12. So when you think about 12, you're looking at 2, 8, because as I mentioned earlier, these are atoms, the number of proton equal to number of electrons. So you're looking at a proton number of 12, therefore you have 12 electrons, therefore it should be 2, 8, 2. So you're looking at group 2. And you're looking at a group 2 where you have 2 electrons in the third shell. In fact, the only group 2 here is this one, 2, 8, 2. Alright, so that will be B. Next bit, an atom of a noble gas which is used to fill balloon. So if they want a noble gas now, so you're looking at either A or E, and you want to look at filling balloons, okay? So A is going to be helium, and E is going to be neon. And the reason I know that is because there's 2 electrons there only, therefore there must be 2 protons. So you're looking at atomic number 2, that is helium. There are 2 shells, so you look at a second period and it's fully filled, so it's all the way to the right, there's neon. Or you can check the configuration is 2, 8, and that will be 10 electrons, and because these are atoms, so there will be 10 protons and there will be neon. Okay, so the one that is used to fill balloon is helium, and helium is label A there. Okay, so it's A. Next, an atom which forms a noble gas configuration when it gains 2 electrons. So they are not necessarily looking for a noble gas, they're looking for an atom when it gains 2 electrons, it will have noble gas configuration. So you're looking at a group 6 because a group 6 element is only 2 electrons short of the noble gas configuration. So we are looking really at D. Okay, is 2 electrons short of the 8 electrons in the outer shell of a noble gas configuration, yeah? So that's D there. Okay. Next bit. So these are given as electronic configurations of 5 atoms. So you know atoms are where the number of protons equal to the number of electrons. So no net charge. That's why they are atoms and they are not ions, right? Okay, and you know that when they share electronic configuration, the number of outermost shell electrons, or we call it the number of valence electrons. In this case, there are 2 in the outermost shells, so we can think about it being a group 2. Okay, and then we also know that the number of shells indicate the number of filled inner shell. So this is the first innermost shell, first shell, second shell, add electron, fill completely, third shell, fill completely, and another electron, fourth shell. So this is fourth period. So actually I can say period 4. So you can see in your periodic table, first period or period 1 is hydrogen, helium. Period 2 goes from lithium in group 1 all the way to neon in your group 8. And then third period is going from sodium all the way to argon, which means period 4 will start at potassium, and group 2 will mean is the second element. So potassium and then potassium and then calcium. So which means this must be calcium, and you can work out the configuration, and they should give you 20 protons, 2, 8, 8, 2. Group number, period number. So these are all coming down to periodicity. Yeah. So here you are 1, 2, 3. You have 3. These are period 3, and these are group 8 because there is 1, 2, 3, 4, 5, 6, 7, 8 outermost shell electrons. I can do for all of them, but perhaps that's not the nature of this question. I'm just showing you how you can address the issues, and it should hopefully help you to answer the question here. Yeah. So they said that each electronic configuration may be used once, more than once, or not at all. And they want to look for sulfur atoms. So sulfur is group 6 and is period 3. So the easiest thing really is look for 6 outer shell electrons. So I already done for these 2 outer shell electrons, 8 outer shell electrons. Here's got 1, 2, 3, 4. So this is group 4. So 4 outer shell electrons. Here's got 1, 2, 3, 4, 5, 6, 7, 8. This is another group 8 element, which means your answer has to be this one because none of these are the answer, right? So 1, 2, 3, 4, 5, 6. In fact, it is group 6 element. Just to confirm, it's period 3. It's got first shell, second shell. The outermost shell is period 3. So that is sulfur there. Okay. A metal atom for part 2. So you're looking at a metal. Well, there's the obvious one there. So A, there's calcium. This is because of group 2 metal, period 4. Okay. An atom with a proton number of 14. So remember I said these are all atoms. So when they're looking at a proton number of 14, so therefore the number of electron in the atom, if I look at atom, is also 14 as well. So what you can do now is, 14 is going to be 2, 8, because 2 electron in the first shell, electron in the second shell. 8 plus 2 is 10, so you need 4 more. So you're looking at 3 shells. You're looking at 3 shells, meaning third period. Okay, you're looking at third period and group 4. So 4 outer shell electrons. This is the only one that is group 4. First shell, second shell, third shell. Okay, I hope that makes sense. An atom of a noble gas with 3 occupied electron shells. Alright, so noble gas, which was this and this, but I think this one you have 1, 2, 3. So this is, oops, sorry, there was group 6. Which one again? This one. This is 1, 2. These are only 2 filled electronic shell, whereas this one, number B, has 3 filled electronic shell. So we're looking at 3 filled electronic shell, meaning period 3, not period 2. Yeah. Next bit, an atom which forms a noble gas electronic configuration when it loses 2 electrons. So we are not looking at noble gas, we are looking at something that will have noble gas configuration after it loses 2 electrons. Between all these, the only type of atoms that will lose electrons are mostly metals, and that also comes back to this being a metal. It would like to lose 2 electrons to get to the electronic configuration of argon. Yeah, so there's going to be A again. Even though you have A already before, but it did say once, more than once, or not at all. Okay, cool. Moving on to part B, what's the meaning of the term isotopes? So these are common definition. So you should know isotopes are atoms of the same element. Okay, that have same number of protons. I need an eraser. Same number of protons, but what is different? Different number of neutrons. So those are basic definitions, so please don't try and get them wrong at all. They now want you to work out the number of neutrons in this isotope. So that is nucleon number. Nucleon number is number of protons and number of neutrons in the nucleus of an atom. So 76 minus 32, that will give you 4, that will give you 44. You can work this with a calculator, of course, alright, but I just found it easier if I just work it out straight away anyway. Next up, you need to complete the table about these ions. So this is a cation, this is proton number, also known as atomic number. This is nucleon number. So the number of protons, first of all, start with proton, that's the easiest, okay? Now you have a 2 plus charge, meaning you have more protons than electrons. So you have lost electrons. That's why you have more proton than electrons. By how many? By 2, because you have a plus 2 charge, you have lost 2 electrons. That's why you're left with 54. Neutron is going to be the nucleon minus 50, the proton. And that is just your definition of what is nucleon number, yeah? So next bit is about counting electrons, neutrons, and protons. Okay, so the number of protons is like the identity of the element. Okay, so that is the proton number for phosphorus, and that means this is also phosphorus because it has the same proton number. So therefore, it's also phosphorus. Okay, but this is an atom. This is an atom. An atom has no charge because the number of electrons balance out the number of protons. That's why there's no net charge. Okay, but here what do you notice? You notice that 3 extra or 3 more electrons than proton. So you must have gained. You must have gained how many? You must have gained 3 electrons. Because you gain electrons, now you are 3 minus. And I have to write in such a form like that. So it's 15 proton and how many nucleon? This top number is called nucleon number. Definition of nucleon number is the number of protons and neutrons in the nucleus. Proton and neutron in the nucleus, 15 plus 16 give me 31. Okay, whereas this one, the neutron is going to be the nucleon number minus the proton number, which will give me 30 minus 15 is 15. Okay, so these two, well, this is actually an isotope of phosphorus, but it's an ion of the isotope. That's why you see it's confusing there. Okay, so this kind of question is meant to confuse students, especially if you are not familiar with what is proton number, what is nucleon number, and what does it mean when you have an atom. Okay, when the number of protons and number of electrons balance out, there's no overall net charge. When you have more electrons than proton, that means you have more negative charge. That's because you have gained electrons. You're going to become anionic.